episode of the roofing trade. In today's episode, we're going to be looking at lengths and angles. And first of all, basically you've got your tape measure, and it's critical to learn what these various measurements are. And so if we're looking at, say, right here is 3 inches, that bold line going across there with 3 in front of it, then this intermediary line right there is going to be 3.5. It's the tallest line in between an inch mark. That's obviously 4 inches right there. So that's 3.5. So that's your most fundamental division of inches. After that, you've got quarter inches, which are going to be right there is 3.25. That's 3 inches right there. There's 3.25. The halfway mark marks 2 quarters, but you always go with your smallest denominator, so you would just say 1/2 inch. But 2 quarters, that there is 3 quarters, and then you're back to 4 inches there. And then after quarter inches, you're going to have 1/8 inches. So right there, it's like the second but the smallest mark. So there's the smallest mark, here's the second but the smallest. So here's 3 1/8, 3 2/8, which we already know is, you would just say a quarter. There's 3 3/8, 3 4/8, which would also be 3 2/4, which would also just be 3.5. Okay, right here is 3 5/8. Okay, right here is going to be 3 6/8, which you always just say 3 3/4. Right here is going to be 3 7/8, and then you're back to 4 inches. Okay, and then the very last measurement is going to be your 16th marks. These are the smallest ones generally on a tape measure. And so right there, 1/16, 2/16, which you just say 1/8, 3/16, 4/16, which is the same as 1/4, 5/16, 6/16, which you would just say 3/8, 7/16, right to the left of the 1/2 inch mark. 1/2 inch would be 8/16, but you don't say that, you just say 1/2 inch. 9/16, just to the right of the 1/2 inch mark. 10/16, which is just 5/8. 11/16, 12/16, which would be 3 quarters. 13/16, 14/16, which would be 7/8. 15/16, and you're back to 4 inch. So when you're counting, let's just go with the smallest denominator. So for example, for a 1/2 inch, you would just say, 1 divided by 2. 2 is the smallest rather than saying 8 divided by 16. They're both the same thing, but it just makes it easier to just use the smallest denominator. So let's count all the measurements going from 3 to 4 inches. So you got 3 inch right there, 3 1/16, 3 1/8, 3 3/16, 3 1/4, 3 5/16, 3 3/8, 3 7/16, 3.5, 3 9/16, 3 5/8, 3 11/16, 3 3/4, 3 13/16, 3 7/8, 3 15/16, and we're back to 4 inches. So let's count that one more time. I'll try to point to the top of the mark this time. So there's 3 inch, 3 1/16, 3 1/8, 3 3/16, 3 1/4, 3 5/16, 3 3/8, 3 7/16, 3.5, 3 9/16, 3 5/8, 3 11/16, 3 3/4, 3 13/16, 3 7/8, 3 15/16, and then you're back to 4 inches. So it's really, really critical in roofing and any other trade that you learn all these measurements and that you can just read them off right away. You want to get really familiar with them. Sometimes something like 11/16 or 13/16 is kind of hard for me, so if I'm right next to like 3/4 inch, then I'll say, okay, 3/4, what would that be in 16ths? Well, 4 would have to be multiplied by 4, so multiply the denominator also. I think that's right term, by 4, so you would have 3 times 4 equals 12, so that'd be 12/16. So 1 to the right of that would be 13/16. Or if you're 1 to the right of the 5/8 mark, well, just multiply by 2, 10/16. What would be right to the next to that? Well, 11/16. So you can take a little bit of time to learn those, but it's so critical, it's so important, especially if you're doing something like standing seam metal, where you want to get your trim pieces exactly right. You want it all to look really crisp and clean. Then you've really just got to know all that stuff. It's good with shingles, it's good with all kinds of different construction stuff. You've got to know that stuff, it's really critical. If your boss asks you to move a ladder over 1 foot and you move it over like that much, which is more like an inch, or you move it like this much, which is like 3 feet or something, or 2.5 feet, you're really going to be trying your boss's patience, because you've really got to know, you've got to have kind of a gut feeling for, how much is an inch, how much is, a foot, how much is a 1/2 inch, how much is a 1/4 inch, how much is 2 inches, how much is 3 inches. And you may not get it exact, but you need to practice and you need to be able to get fairly close. For example, when you're popping the line for laying your lay-on shingle in a California cut valley, a lot of times they'll come up like 2 inches, from the center line of the valley. And so, if you're the guy at the top of the valley and you're holding it at like 6 inches and you think you're holding it at 2 inches, and the guy at the bottom's, he's holding it at 2 inches, but he's being correct with it, that valley's going to look horrible, and you're just going to like waste a ton of shingles just because you didn't know the difference between 6 inches and 2 inches, or you weren't able to guess and get pretty close at what 2 inches is. So, and some things that can help, like 1/2 inch, that's pretty much what plywood or OSB is going to be for the most part. It's maybe more like 7/16 or 3/8 sometimes, but it's usually very close to 1/2 inch. So if you just think of like what is the thickness of decking or sheathing, then you'll be pretty close to that 1/2 inch if you're able to think about it that way. An inch would just be 2 times that thickness, so about that right there. I can test it on my thing, and in fact I am right at 1 inch just by guessing. 1 foot's another one that you need to know. 16 inches is another one. A lot of times studs will be placed at 16 inch on center, so like here's a stud, and then pull from that stud 16 inches over to the face of the new stud, or center to center, same thing. That'll be 16 inches usually. So if you're like estimating, it's new construction, you see studs, sometimes you can just count the studs, 1, 2, 3, 4, 5, 6, 7 studs times 16 inches if they're all spaced at that 16 inch center, and then you can figure out what that is. Also, sheathing is going to be 4 foot by 8 foot, so sometimes you can use that to count, the slant height of a roof on new construction, because you can see, well, there's one sheet that's 4 foot wide, here's another one, and then there's about half a piece there. So you can get, you can say, okay, 3.5 times the 4 feet gives me, 14 feet. So, it's just a good way to just quickly get something, especially if it's like a steep roof and you don't have time for harnesses and all that stuff. You can just stand on the floor below and get that. So, understanding lengths and being able to kind of estimate some basic lengths is so critical. And, you've really just got to know that if you're going to be in construction. So go ahead and learn that stuff. Right here I've kind of drawn out some of the various measurements. So there's like 1 inch, there's 1/2 inch, there's a 1/4 inch, there's an 1/8 inch, there's a 1/16 inch. And on paper this looks a little bigger than what you think in your head. If you look at it on the tape, it almost looks smaller, like a 1/2 inch or a 1/16 inch looks smaller than what it does on paper. That's probably just an optical illusion, because I did measure these all out. So we've kind of looked at lengths. Now I'd like to also look at angles. And by the way, the term trigonometry comes from Greek. It's a combination of trace, which means 3, gonias, which means bends or angles, and metron, which means rules or measure. So basically it's saying like rules of the triangle, or rules that we can apply to a triangle. A lot of times trigonometry has to do with right triangles, or one of the angles is going to be a 90-degree bend, such as you see on a square, like that right there, 90-degree bend. And then as long as you know one angle and one side, you can figure out all the rest of the side lengths and angles. So if you know that that's like 4 feet, and you know that one's going to be 4 feet, and that one's going to be whatever. If you know that that's a 45-degree angle, which we do because it's a speed square. So 90 degrees there, 45 there, 45 there. A lot of times your right triangles will have one side that's different than the other, but it'll still be a right triangle. So one angle that's 90 degrees, and then let's just say that this is let's say that's 1 foot, and this right here is 4 feet. So that'd be 48 inches. This would be 12 inches. This, incidentally, is the proper angle that they say for your ladder to be set on. So for every 1 foot horizontal, 48 inches up, or a 48 on 12. Now, incidentally, if we rotate that, right now we're calling the 12-inch the run, and we're calling the 48-inch the rise. But if we were to rotate it like this right here, this becomes a 3 on 12 triangle, because again, if we've got a 1-to-4 ratio, that's essentially the same as a 3 to 12 ratio. Just multiply both numbers by 3. 1 times 1 inch times 3 would be 3 inch. 4 inch times 3 would be 12 inch. So that'd be 3 on 12. For every 12 inches of run, 3 inches of rise. And so basically, that same angle for the ladder becomes a 3 on 12 if it's like inverted. So an inverted 3 on 12 is a 48 on 12. And we can actually confirm that with a square as well. So this right here is a speed square, and if we were to look at like a 3 on 12, that comes to about right there, about 15 degrees, a little bit less. So the complementary angle would be 90 minus about 15, so it'd be about 75, maybe a little bit more. So it'd be about right there, and as you can see, there's 30 on 12 right there, and it's going up pretty fast, so I'm sure by the time it gets right there, that's where you get the 48 on 12. It's not a perfect confirmation, but it shows that it is true. I mean, I've already done the math, but I'm just saying, if they'd extended their marks out further, we could see that it was, that was the case. Let's say you've got a 4 on 12 roof and you want to find the complementary angle. You just come down here, find how many degrees it is, 10, 15, 20, it's right there at 19, okay? So about 20, so 90 minus 20, but add that degree back, gives you about 71 degrees. So about right there would be your inverted 4 on 12, or the complementary angle to a 4 on 12, which looks like about, 30 something on 12 looks like. We could also say, let's go with an 8 on 12. 8 on 12 right there, it's about 35 degrees, maybe a touch less. So 90 minus 35 would give us 55, maybe a touch more. So about right there, about almost 18 on 12 for the complementary angle. So let's also talk a little bit about using speed squares. Again, we said that basically this is your 90 degree, and this angle here happens to be 45, that one happens to be 45. But what you'll end up doing is you'll have like a 2x6 or something. Let's just say that this is your 2x6 here. It looks more like a 2x12, but let's just say it's 2x6, and you've got to put a head cut for the rafter. Let's say you're a framer, and let's say that you want to get your roof is a 6 on 12. Okay. Well, we just find where the 6 is on this top cut common, which is like right there. It's the bottom measurements, not the angles, not the degrees, but the rise on run common. Just line it up right there, that stays flush, and then we would just mark, not along there, we'd actually mark along right here and cut that off. And then when we take this rafter and put it up there, it's going to meet up just perfectly with that ridge, if it is a 6 on 12. If it was like a 12 on 12, then you would just swing this out until you hit the 12 on 12 mark. You draw that same line, cut it off, There's your raft right there. Put it in place. It's going to get right up there with that ridge, just exactly properly. So that's kind of the basics of the speed square. If you'll notice, not only do they provide you with degrees here at the bottom, they also provide you with the like 4 on 12, 6 on 12, the like rise over run, description for common rafters. And then this line up here on the top is maybe a little bit confusing, but basically what it is let's say that you've got a 7 on 12 roof, okay? So that's like right there, all right? So they're trying to make it like easy for you, but in doing so, they might make it like too easy if you like, or one of those people that like me likes to like think about things like correctly and stuff. So, they've made it just really correct. They've made it like really easy. So they're just saying, hey, you got a 7 on 12 roof, so here's your mark for the hip and valley rafters, okay? So, but I like to like actually think about things and say, well, what is that, Well, it looks like it's about a 5 on 12, okay? So when you've got a 7 on 12 common rafter, your hip or your valley angle is going to be closer to about a 5 on 12. And I've actually got a chart that gives you the exact measurements, based on these numbers, what is your hip valley measurement going to be, and also it gives you another triangle. Let me just show you. So when we're looking at these bottom numbers, those are just the 7 on 12. That's like the slope of the roof. Let's say this is a 7 on 12. That's it right there. Okay, so that's like that's like that triangle inside of there. If we were to pull it out, it would look like that right there, and it would be, for every 12-inch run here, you'd have 7 inches of rise. Okay, and then for this hip, it's like you're rotating it, and it's that triangle, pretty much the same, except we're looking at it from a hip point of view now. So it's like, it's like that right there, and now for every 12-inch run there, you're going to have a little less. It's going to be 5 on 12. So this is always going to be a little bit less, unless you got some funky situation. And then there's a third triangle, which is like this one right here, that triangle right there. If you like take it out and stand it up, that's useful for like determining lengths of hips, lengths of valleys, unknown measurements on the roof. I use it a whole bunch when I'm measuring a roof. So that's an important measurement to know also, and it's not listed on the speed square. So just FYI, that one's not on there, that third triangle, but I'll have another video that kind of goes over that and explains it. So yeah, I think that's about all that I'm thinking of. These guys here are called speed squares. This one is a plastic speed square, and it's really good for working with standing seam metal where you don't want to scratch the coating, like you got a painted standing seam metal roof. These metal ones, they will scratch it up, if you're not careful. Really, they'll scratch it really easily. These plastic ones, they don't scratch it because the plastic on there just doesn't scratch. So I like using those. Those are good. This is just another variety here. That one's by Stanley. That one's almost a little bit easier to read. And it also got like a little tape measure on the top for you there if sometimes I use that to just quickly get a measurement if I don't happen to have a tape for whatever reason. And then there's also this square here. This is called an L square. I think it's also called a framer square. It's good for like laying out stairs and stuff. A lot of times you'll pop like these little holder pegs, one here, or one here, one here, to kind of establish, what your tread, run, and rise is going to be on your stringers for your, when you're framing stairs. They'll lock it in place, and then you can just draw it over and over for each step, go along the way. Cut out a pattern rafter, or a pattern stringer rather, and then, as long as that one's good, then you'll use that to like trace out your other 2 or 3 stringers. A lot of times people will do that. So L square, plastic speed square, metal speed square, and of course, the trusty tape measure. So I think that wraps this episode up. Thank you for watching.